Hi, I'm Dipali Chandel, and this tutorial is a continuation from the previous NLP tutorial. And in the last class, we covered till POS tagging. Now, today we're gonna start from the named entity recognition, NER. Okay, so basically, you can see what is named entity recognition. We have to recognize the named entity. That means the named entity over here, you can see the example WHO. This is of organization type named entity. President Obama, he is person type of named entity. Okay, so basically NER automatically scan the entire article and pull out some fundamental entities like people, organizations, places, date, time, money, and GPA. Okay, as we can see in the below example. Fine. So you can see Mount Everest is kind of location named entity type. Then this date is of date entity named entity type. Okay. Similarly, over there, this location Northwest America, this is of GPE named entity type. Okay. Now, this I am from India, so this India is kind of GPE. I want to work with Google, so this Google is organizational named entity type, and Steve Jobs, he is person named entity type. Okay. Now we have two options for the named entity. First is when we do the binary equal to true. What does this mean? It will only show whether a particular entity is named entity or not. Okay. Now let's see that. So for that we have to do the basic imports. After that I will import word tokenize over here. Now this is my sentence that I stored in the variable sentence. After that I am doing word tokenization process on this variable sentence, and as you can see I am applying the for loop over here. So after we are doing word tokenization. So this will over here you can see this will be first word, then this period will be the second word, then Smith will be the third word. Now this W, what is the value of this W for the first time? MR. And what is the value of this W for the second time? Dot. And what is the value of this W for the third time? Smith. Fine. Like this it will follow till the WHO. Now over here we are doing the pause tagging using the pause tag function from the NLTK module, and in this I am passing the output of the word tokenize function. Okay, now it's gonna give me the list in which there will be tuples which contain the word and the corresponding tag to that. Fine. Now how to apply the named entity recognition function. So over here for that we have any underscore chunk function. In that I will pass this tagged word which contain output after the post tagging. Okay, that you can see. Now over here this parameter I am making it true. Now what will happen? It will give us only the output whether that word will be named entity or not. Okay, now see. So you can see this MR is named entity and this is of noun type. Okay, Smith is also named entity. Then these all words are not named entity. Now this is also Switzerland, this is also named entity. Okay, and this WHO is also named entity as you can see over here. Fine. Now the visualization part of it. So you can see the visualization part of it over here. Fine. So you can see like it is giving you this is named entity, Mr. and then Smith, both are named entity. Then Switzerland is also named entity and WHO is also named entity. Fine. Now coming below, second option, when we make the binary parameter equal to false. So it's gonna give us, it will show the detailed type of the named entities, like whether it is organization, whether it is person type, or whether it is location type, like this. Okay. Now, so just one change over here, you have to make that binary equal to false in the above code. Okay. So let's run it. So you can see. Okay. So when we run it, okay. So you can see the output over here. This MR dot is of person type, then Smith is also of person type named entity. Okay. Then the Switzerland is GPE type named entity, and organization, this WHO is organization type named entity. Okay, now what will be the output for it? See, Over here we can see this MR is of person type named entity. Smith is also person type. Then Switzerland is GPE type named entity, that is location, and WHO is organization type named entity. Fine. Okay. When you run it, you will see the output like this over here. Okay. Fine. Okay. Now we are crossing it. Now going further. Now, what is chunking? So basically, see what happens. Chunking means we have to extract the meaningful phrases from the unstructured text. Okay. So chunking basically means breaking the simple text into the phrases that will be more meaningful than the individual words. Okay. Now this chunking process works on the top of POS tagging output. So POS tagging output, it takes as input and then it provides chunks as the output. That means groups of words which will be phrases, which will be phrases, and those will be more meaningful as compared to the individual words. So we can have these many types of phrases: noun phrases, verb phrases, adjective phrases, adverb phrases, prepositional phrases, like this. Now in the below code, what we're gonna do, we will define with the help of the regex. Okay, we're gonna define a noun phrase. We will do the chunking for a noun phrase which will be okay, which will have an optional determiner followed by adjective and nouns. Okay, we will chunk out a noun phrase which contain optional determiner followed by adjective and nouns. So that regex expression for it will look like this. Fine. So we will chunk out a noun phrase which will contain an optional determiner that will be followed by adjective and nouns. Fine. Now, so over here, this is my sentence. Then I'm doing word tokenization on that sentence variable. Then I'm applying for loop for each word, okay, on that of that sentence, okay, after doing the word tokenization, and I'm doing the pause tagging on that. So it will give me a list, okay, which will contain tuples, and these words along with their tags will be the output. Okay, like a will be a I guess determiner, then variable will be a adverb. Like this, we will get in a list, we will get tuples which contain these words along with their tags. Fine. Okay, now we are writing the grammar over here. Okay, now I'm passing this grammar in the regex p parser function. Fine. Now I am applying the object with the help of this object, which is of this regex p parser function. I'm using this object on the parse function, in which I'm passing this tagged words variable, which contain output of the post tagging, Now let's see the output for it. So you can see over here how it's look like. This is a chunk. Okay. Okay, this is noun phrase which contain beautiful as adjective, young as adjective, and lady as noun. Then this is another noun phrase which contain da as determiner and beach as noun. Fine. Now see the output. So this is that noun phrase which contain beautiful as adjective, young as adjective, and lady as noun. This is another noun phrase which contain the as determiner and beach as noun. Okay. Fine. So this was chunking. Another little bit big example for the chunking is this one. So over here we have a quote. This is complete a string. I'm passing this quote in this word tokenize again. Then we are applying the post tagging on that. Then we will get the we are printing the output after the post tagging, and the output after the post tagging will be this one. Okay. Fine. Now we are applying, we have written this grammar over here. Now same as the previous one, we are passing this grammar in the regexp parser function. After that, with the help of the object of this regexp parser function, I am passing this text variable which contain the output after the post tagging inside this parse function. Okay, and it will give me, we can say, the chunks. Okay, so this res variable will give me the output of the chunking process. Fine. hold on. Fine. So we can see that. So what is the output for that? So this output, this is the output after the post tagging. Okay. This is the output after the post tagging, and the output for this one is that you can see over here. Okay, fine. Now how to see that output? So this output is over here. So what we have written? We have to take out that phrase, that noun phrase in which we have determiner as we can say as optional, and then followed by adjective. Okay, and further followed by noun. So you can see this is noun phrase, that is another noun phrase is this one, then this is noun phrase, then this is noun phrase, then this is noun phrase, and this is noun phrase. This is complete big. So I can make you visualize it completely. Okay, fine. So this was chunking part. Now coming to the chinking. What is chinking? See, after doing the chunking, we still have some words that we still want to remove. That is not more useful. So we can do this chinking process for that. Okay. So what is chinking? Basically the chunk, okay, that we want to remove from the chunk, from the chunk part, you can say. The chunk that we want to remove from the chunked part. That process is known as chinking. So in the following below example, we are going to take the whole string as a chunk, and then we are going to exclude adjectives from it by using chinking. Okay. So for that, this is a sentence. Fine. Now I am applying word tokenize on that sentence. Then I am applying for loop for each word of the tokenized words variable. Okay, and applying post tagging on that. Now I will get in the tagged words variable, I will get the output will be a list which contain tuples. In those tuples there will be words along with their respective tags. Okay, now this is my regex expression. Fine. So I want to exclude the adjective part. For excluding part, for we can say for the chinking, when we want to exclude anything, then we have to write that in the inverse curly braces. Okay. So out of a complete sentence, I want to exclude this adjective part. Okay. That means I want to chink out this adjective part. Again, so I'm passing this grammar into the regexp parser function, and the object of this regexp parser function we're going to use along with the parse function, in which I'm passing the output of the post tagging. Okay, I'm passing the output of the post tagging. Then we are looking at the output, and then we want to visualize that output. Fine. So let's run this part as well. Okay, so you can see this is my beautiful is adjective which is chinked out. Okay, this is a chink. This gets chinked out. So this beautiful is getting chinked out. Fine. Now let's see that part. See, over here, this is my complete noun phrase, and this is my complete noun phrase, and this is my chink part, because we written excluding the adjective. Okay, excluding the adjective. So this beautiful is adjective which is chinked out. Fine. Okay. Now coming to the next topic, which is stemming and lemmatization. So what is stemming? It is the process of reducing a word to its root word. Simple. It removes the suffix or prefix. Okay, like loved will be reduced to love, and learning will be reduced to learn. We will see the difference between stemming and lemmatization. Before let's understand the definition of it. Then coming to the lemmatization, it works the same as stemming, but the key difference is it returns a meaningful word. Context. By looking at the context, it returns a meaningful word. Okay, fine. Now let's see what is the example of stemming. History got stamped as historic, and over here after lemmatization process, this history will remain as history. Why? Because this history does not have any meaning, but this word history has meaning. Fine. So basically in stemming, we just remove suffix or prefix. But in lemmatization, what we do? We find out, we can say, in lemmatization, we find out that base word which is meaningful, okay, related to the context, to the meaning of that word which we want to do lemmatize. Okay, so was is reduced to be, better is reduced to good, and meeting is reduced to meeting. Okay, now in the lemmatization, we take into account the part of speech values as well, like verbs, nouns, adjectives, and adverbs. We will look around it how we are gonna use them. So we have various stemming algorithms. The most, we can say, most famous algorithm is Porter's stammer. Further, we have these stammers as well, but out of them, only Porter's stammer is most important stammer. Fine. Now, what is the difference between stammer and lemmatizer, coding wise? So, see, this studies word over here. First, we have to import the Porter stammer from the NLTK.stam library. Okay. Then we're gonna create the object of this Porter stammer class, that is stammer. Okay. Now, with the help of this object, I gonna use this stem function. I'm gonna apply this stem function on the string studies. So it will give me, obviously we are doing stemming, so it will not return us the meaningful. It might or might not. Okay, so it is returning us study, that is to study, which does not have any meaning. Now let's look around at lemmatization. So during lemmatization, the word studies will be reduced to the study, study, as we can see over here. Okay, now so this study has a particular meaning. Okay, fine. So we can see like what is the difference between stemming and lemmatization. Now for that, first we have to import the WordNet lemmatizer, and then we have to create an object for that WordNet lemmatizer class, and then we're gonna apply, with the help of that object, we're gonna apply the lemmatize function on the string studies. Fine. Okay. Now let's see this. I'm passing this complete list, okay, in the lemmatize function with the help of post tagging v, okay, that is verb. So it will gonna return us verbs only. Fine. Now see over here, WordNet lemmatizer. I imported the WordNet lemmatizer. Then the object of this WordNet lemmatizer class is lemma. Then I applied the for loop for all the words in the word list. Then this, with the help of this object lemma, I gonna apply lemmatize function on each word. Okay, and it will gonna return me, we can say, lemma, which is verb. Okay, so for the study we got study. For the studies we got study again. It is a verb. Then again for the studying we got study, and then for the studied as well we got study. Okay. Now, so the default value of POS in lemmatization process is noun. Okay, now let's see the below example over here. So I didn't mention the POS, so default is noun, that is N. Okay, so it will return, for the studies it will return me study. We are doing the lemmatization. For the leaves it will return me leaf, and for the decreases it will return me decrease. Okay, and for the plays it will return me play. Fine. Now the below example, as you can see over here, over there I am passing a list which contain these words, these strings. Okay, now again, over there, POS is V, that is verb, so it will give me a verb of all these words. So what is the verb of all these words? V, lemma verb, we can say. Okay, after the lemmatization. Fine, we are doing the lemmatization over here. Fine, so I hope this was clear to you. Okay guys, so in the next class we will continue with the same NLP concept. Thank you very much.